Hello, I'm Wade Hodges, CEO of Nevada Exploration.
And I'm James Busgard, President. And today we're reviewing the latest results from our Southgrass Valley Carlin-type gold project and presenting our plans for our next phase of drilling. As we do so, we will be making some forward-looking statements. This video is a follow-up from the video we released in November 2019 after our initial core drilling program at the project, where we looked at the geologic building blocks that created Nevada's largest Carlin-type camps. We explained why we believed we had confirmed the presence of these same building blocks at Southgrass Valley, and we outlined our objectives for our next phase of work, including a reverse circulation or RC drilling program to collect more detailed information at 4 specific target areas. This drilling began in January and ended in April, and based on the results, we're excited to share how we're narrowing our search for Carlin-type mineralization to an area we've named East Golden Gorge. With this latest video, over the next 25 minutes, we're going to highlight the major geologic features to orient those new to the project, explain how the results of our latest work have led us to East Golden Gorge, and most importantly, lay out our next stage plans to advance the project.
Large Carlin-type gold deposits cannot exist in a vacuum. The mineral systems responsible for Nevada's major Carlin camps are products of specific geologic conditions that through their life cycle permanently affect the bedrock that surrounds them. And together these form the clues that we follow to search for new deposits. Specifically, we're looking for places where large volumes of mineralized hydrothermal fluids have moved along major fluid pathways to intersect favorable host rocks at the time and place where the surrounding conditions force the fluids to deposit their gold. As we shared in our last video, Southgrass Valley is a covered project we identified based on high concentrations of gold in groundwater. To explore for Carlin-type gold mineralization at a covered project like Southgrass Valley, we start by looking at what's exposed in the surrounding rocks, and then begin to integrate other tools such as geophysics and drilling to fill in the blanks across the areas that are covered. Here at Southgrass Valley, there are typical Carlin-type carbonate host rocks known as lower plate, sticking out of the gravels at the north end of the project, exposed at Goodwin Butte. These favorable host rocks are also exposed at the south end of the project, where they show us the stratigraphic relationships between the bedrock units and give us the opportunity to collect important structural information. These disks represent places we've visited to record measurements that we use to establish the project's overall structural fabric, which allows us, at a large scale, to map major faults and structures that could provide the primary source for mineralized hydrothermal fluids, and at a smaller scale identify secondary pathways for the fluids to move from their source to where they may have dropped their gold. To project the features that we can see exposed under the rest of the project where the bedrock is covered, we completed 2 geophysical surveys. The results of our air magnetic survey suggested that the lower magnetic, lower plate that we see in outcrop continues under much of the project, gave us an indication of the extent of the higher magnetic granitic rocks, and indicated the presence of a likely structural related regional scale north-northwest corridor. The results of our gravity survey suggested that the depth to bedrock across much of the project is relatively shallow, and provided secondary support for the north-northwest feature seen in the air magnetic survey. Having confirmed the projection of suitable host rocks along a major structural corridor, we then needed evidence that this setting had been exploited by gold-bearing hydrothermal fluids. And for this, we completed 2 geochemistry programs, collecting both groundwater and soil samples across a large portion of the project. The results define discrete clusters of elevated pathfinders along the projected intersection of the lower plate in a north-northwest structural corridor, and gave us the geochemical support that the project contained the building blocks to potentially host a large Carlin-type mineral system. To test this concept, from 2018 through 2019, we completed 10 wide-spaced core holes. Our objectives were to confirm the presence of the features we'd projected under cover, and to test whether this favorable setting had seen the massive hydrothermal fluid flow needed to source a large gold endowment. As we shared in our last video, this is exactly what we found. The combined data from our drilling, mapping, and geophysical surveys define the classic geologic architecture of a Carlin-type district, with a complex regional scale structural fabric cutting through a thick package of reactive lower plate along the margin of a major intrusive. Then, most importantly, within this architecture, the drilling encountered widespread alteration, including intense silicification, multi-phase sulfide and oxide mineralization, together associated with gold and highly anomalous pathfinders over more than 3.5 kilometers. The scale and intensity of these features seen in our initial core holes established that this favorable setting had been exploited by a large mineralized hydrothermal system, with a characteristic budget of gold and associated pathfinders. In all, the results confirmed the presence of a Carlin-type mineral system large enough to potentially support multiple deposits, and provided the basis for our geologic model that we're now using to integrate each of our exploration data sets. This was a big milestone for the project. Though while we believed we had successfully discovered an important new mineral system, at this point our model was anchored by only 10 wide-space drill holes at what is a district-scale project, which brings us to the next phase of work, which we've recently completed.
To advance this large, still early-stage project, our next job was to look for the features that control the mineralization we'd found, and for this we needed to significantly improve the resolution of our geologic model. With this next phase of work, we integrated our geophysical datasets with our core samples to more clearly define the structures and boundaries between rock units, and then added more drill holes to give us the density of samples we needed to look for potential mineral controls. Beginning with the geophysical component, using the core samples, we collected density and magnetic susceptibility measurements from the units we encountered in the drilling, so we could directly relate them to the results of our geophysical surveys. With these inputs, working with Mirror Geoscience, we created a constrained inversion model to refine the projections of the rock units and structures from the areas we had drilled and mapped to the areas we've not yet drilled.
The first output was an updated geometry for the Grass Valley stock, whose shape is important because the margins of similar intrusive rocks represent controls for mineralization at Nevada's largest Carlin districts, specifically in areas where favorable lower plate rocks meet the margins of intrusive rocks, as we have here in this central part of the district. The next output was a surface representing the top of the lower plate bedrock, sitting underneath the gravel and more recent volcanic and mud flow units that shows us what it looked like before it was covered. The surface mapped a distinct canyon-like topographic feature that we believe marks a series of regional scale, high angle, and related damage zones. The modeling also showed that the mud flow above the lower plate is largely controlled by this feature, consistent with how we'd expect it to flow when constrained by such a canyon. Moving from the model back to our drilling results, the structural corridor is well supported by massive damage zones and other structural features in the core holes. While we had suspected its presence based on our early interpretations, the results of the constrained inversion modeling have improved our confidence in the projection of this feature, which we've now named the Water Canyon Structural Corridor. Such deep-seated, long-lived structures represent critical building blocks for Carlin-type mineral systems, and establishing its location was a big step forward in understanding the potential primary source of hydrothermal fluids for the districts. With this improved geologic model, we are in a good position to integrate new data from our next round of drilling for the purpose of establishing the potential controls for mineralization.
To maximize the new drill holes we could add, we switched from core drilling to less expensive RC drilling. And to guide the distribution of the holes, we grouped them in areas that showed promise in terms of their geologic setting based on our model, and that were also supported by elevated gold and pathfinders based on our drill, soil, and groundwater samples. To show how we integrate this geochemistry data with our geologic model, we're going to turn on the results of our groundwater sampling. Through drilling more than 200 sampling boreholes, we established the direction of groundwater flow across the project from the southwest northwards towards the center of the basin. When we review the pathfinder concentrations, in this case gold, something clearly changes as the groundwater flows across the middle of the project, where large amounts of gold are being added before returning to background with distance to the north. Exploring this data in 3 dimensions, we see an initial first zone of enrichment, which is followed by a second zone of enrichment. By overlaying this geochemistry data onto our geologic model, the first zone of enrichment, which contains some of the highest concentrations of gold in groundwater we found anywhere in Nevada, corresponds with the margin of the intrusive, where our favorable lower plate units border the Grass Valley stock. And the second zone of enrichment sits directly above the large alteration in geochemistry features seen in the core holes, which is also coincident with the largest geochemistry anomaly in our soil sampling. Using this integrated model, we selected 4 target areas to locate our RC drill holes. The first 2, Freddy and Golden Gorge, corresponded with the 2 dominant golden groundwater anomalies. The third, Water Canyon, focused on a weaker groundwater anomaly along strike with the first 2 based on the projection of many of the same geologic features. And the fourth, Waterfall, focused on evaluating the possibility that some component of the golden groundwater at Golden Gorge may have been sourced from this direction. To discuss how the latest RC drilling results from each of the 4 target areas have advanced the project, I'm going to turn it back to Wade.
As James explained, having discovered a district-scale Carlin-type mineral system with our initial core holes, the goal for our next phase of work was to investigate what controls the mineralization. By spreading the holes across these 4 initial target areas, we set ourselves up for collecting a wide spread of new information, while also providing the density of data to answer questions about mineral controls in a number of locations. So let's look at the results. Beginning at the north, we're going to zoom in on a cross-section that cuts through one of our initial target areas called Freddy. Based on the intensity of silicic alteration and Carlin-type pathfinders in the initial core drill holes, we had preliminary evidence that a unit we call CLM had seen the most hydrothermal fluid flow. This Cambrian-age limey mudstone sits immediately below a less permeable and less chemically reactive laminar shale and calcareous siltstone, and represents a typical Carlin-type gold host environment. With our RC holes, we were looking to determine the extent of the mineralization seen in the initial core holes, as well as look for potential mineral controls, including the association with the CLM unit. In particular, we were looking to test the shallower, up-dip extension of these features for increasing concentrations of gold and pathfinders. With the additional samples from 5 new RC drill holes in this area, the results confirm that the intensity of the alteration and pathfinders is strongly related to the CLM unit. The drilling also extended the size of the alteration features another kilometer to the west-northwest, which highlights the massive scale of the system. In terms of testing this up-dip extension of the alteration features, the now larger dataset shows that the pathfinder concentrations decrease up-dip, which is also consistent with the intensity and zonation of the alteration, where the more intense silicification at depth transitions to more distal argillization towards the surface. Together, what we're seeing are multiple vectors, all of which point to stratigraphically controlled fluid flow having traveled laterally up-dip along the CLM unit from a primary source coming from the direction of the Water Canyon structural corridor. Based on the evidence that the CLM unit provided a dominant control for lateral fluid flow, our plan for our next phase of exploration is to follow the CLM unit down dip, closer to where it intersects our suspected source of the mineralized fluids, and, as we'll continue to see, this intersection of the CLM unit with the Water Canyon structural corridor defines what we're calling our East Golden Gorge target, where we're now focusing our efforts. For our next stage of drilling, here at the northern end of the project, we're proposing 6 core holes for a total of 7,500 meters to test the full thickness of the CLM unit for potentially economic mineralization, where it dips closer to the potential fluid source. The same general patterns in terms of results and our next stage plans that we've just reviewed at the north end of the project repeat again as we move southward down to the next of our initial target areas, called Golden Gorge. Compared to Freddy, Golden Gorge is located closer to the Water Canyon structural corridor and bounded to the west by the Grass Valley stock. Our initial wide-space core holes confirmed the presence of anomalous golden pathfinders within silicified and marble breccias in the lower plate close to the margin of the intrusive. Similar to what we were looking to accomplish at Freddy, at Golden Gorge, our goal with the RC drilling was to test the up-dip extension of the favorable alteration and geochemistry features we'd seen in the core holes, as well as to test for mineralization at depth where these features meet the east flank of the intrusive. Looking at the results, in terms of testing for mineralization along the margin of the intrusive, our shorter than expected drill holes only sampled a portion of this vertical zone. They did, however, encounter significant silicification associated with highly anomalous pathfinder geochemistry over thick intervals. The scale and intensity of these features in these holes close to the intrusive suggests localized zones of vertical fluid flow, which could represent an important setting for mineralization. If we look beyond the intrusive margin, while we still need to see some deeper holes, the zonation and intensity of alteration we're seeing increases at depth, along with the Carlin-type pathfinders, towards what we believe was the primary source of the hydrothermal fluids. Together, the results at the Golden Gorge area are consistent with mineralized hydrothermal fluids being sourced from the Water Canyon structural corridor and flowing laterally along the coelom unit until they hit the Grass Valley stock, where they are forced to then move upwards, vertically along its margin, closer to the surface. The intrusive's influence on effectively stopping the westward flow of the fluids is likely the reason why we encountered relatively little alteration in the 3 drill holes we completed up dip at Waterfall, another of our initial target areas. When we review all of the data, just as at Freddy to the north, based on multiple lines of evidence, in this middle part of the project, we're narrowing our search to mineralization associated with lateral fluid flow through the coelom unit, up dip from the Water Canyon structural corridor, which represents the continued southern extension of our East Golden Gorge target. To advance this area where the target begins to be constrained by the Grass Valley stock to the west, we're proposing 4 core holes for a total of 5,000 meters to test for potentially economic mineralization within the coelom unit upwards from the believed primary source, as well as associated with the more vertical fluid flow along the margin of the intrusive. Zooming back out from where we started at the north to where we've just reviewed the results here in the middle of the project, the geologic setting that defines East Golden Gorge continues to project southwards, opening up as it moves beyond the intrusive. With geochemistry support from elevated golden pathfinders in groundwater and anomalous mercury and arsenic in soils at surface, we chose to take a large step out 2 kilometers south of our initial drill holes to add data in this area of the project we've named Water Canyon. Due to challenging drilling conditions, we limited the scope of our investigation at Water Canyon to collecting preliminary geologic information from 2 drill holes. Both relatively shallow holes encountered narrow intervals of likely structurally controlled silicification associated with anomalous pathfinders that have provided early evidence that the fluid flow we believe is responsible for the mineralization at Freddy and Golden Gorge may have well extended much farther to the south. However, the intensity and scale of the alteration and geochemistry in these holes are weaker and less widespread than we saw to the north, which suggests that the shallow units we drill were likely peripheral to the main fluid flow, and that any mineralization in this area is likely deeper, possibly related to the southern extension of our East Golden Gorge target, where the coelom unit projects upwards from the Water Canyon structural corridor. Beyond testing the lower plate, the holes also sampled the alluvium and bedrock above, including the mudflow unit sitting directly on top of the lower plate. Of particular note, within the mudflow, we encountered mineralized boulders similar to those we saw in our initial core holes. Based on our modeling of the lower plate surface, we believe that these boulders are representative of lower plate that was exposed at the time the mudflow was deposited, which tells us that the mineralization we've only so far seen at depth was likely exposed at the surface in some areas. The modeling also suggests that the mudflow and the boulders within it originated from the south, which provides another clue that the mineralized corridor we're following may continue in this direction. It's still early days at Water Canyon, though for now, this large step out has not only helped to validate and improve our overall geologic model, but has also given us some geochemistry support to continue to explore southwards. As we learn more about the larger district, with more drilling to the north, we'll be in a better position to consider how to best add more data in this area.
Returning to our main area of focus. In summary, when we review the results of our 2 drilling programs as a whole, what we're seeing is a typical Carlin-type geologic setting with characteristic alteration and anomalous geochemistry across several cubic kilometers of bedrock, which remains open. By integrating the results of our drilling and mapping with the data from our geophysical surveys, we believe we have established the primary source for the mineralized hydrothermal fluids responsible for these Carlin-type features, namely the Water Canyon structural corridor. Based on the intensity and zonation of the alteration in gold and pathfinder concentrations, there's strong evidence that the secondary lateral movement of the fluids through the district was stratigraphically controlled within a Cambrian-aged limey mudstone that we call the CLM unit. With a handle on what we think are both the primary and secondary controls for the mineralized hydrothermal fluid flow through the district, our focus has narrowed to where the CLM unit dips closer to the Water Canyon structural corridor, representing the geologically constrained target called East Golden Gorge. To test East Golden Gorge for Carlin-type mineralization, we're proposing a program of carefully targeted core holes designed to sample the full thickness of the CLM unit along a 3.5 kilometer length of the target. As we plan this ambitious drilling program, we want to highlight what differentiates the target from other early-stage projects in Nevada. Most significantly, compared to the size of the mineral systems hosting some of Nevada's largest deposits at the north end of the valley, we believe the size of the target and the scale of its associated alteration features support the potential to host an entire new district. Our next stage program is designed to test for both a flat-lying type geometry, similar to that of Goldrush, in our case associated with the stratigraphic hosted mineralization with the CLM unit, as well as for more vertical hosted mineralization, similar to that at Cortez Hills, associated with the breccia features we're seeing and the margins of the Grass Valley stock. To ensure the spacing of our proposed holes is suitable to test for this more vertical type orientation, we've placed them an average of 600 meters apart along the length of the East Golden Gorge target. As we continue to advance and de-risk this district-scale target, we believe strongly that in today's covered search spaces, geology is what drives discoveries. From the beginning, we've taken a systematic approach to building the geologic framework we're now using to target mineralization based on the latest research on the features and processes responsible for Nevada's largest Carlin-type gold districts, as well as by integrating new exploration tools. This is the exact geology-driven process being used by the world's largest mining companies, and we believe, based on our results to date, that we have the opportunity here at South Grass Valley to make a significant discovery at a completely covered and otherwise blind project that we discovered as a result of our industry-leading groundwater chemistry exploration program. With more than 55% of its bedrock hidden under cover in its valley basins, unquestionably the future of exploration in Nevada is undercover. For every Carlin trend exposed in the mountains, there is another potentially waiting to be found undercover, and we've built Nevada Exploration specifically to apply the best geoscience to search for this second half of Nevada's Carlin gold endowment. We thank you for watching. It's been our pleasure to share our approach to exploring for what we believe is the biggest prize in the industry, and we invite you to follow our continued progress at www.nevadaexploration.com.